All right, fellas, so welcome back. Moving on to chapter 10, Circles and Circumference. Let's just get right into it. Okay. So by the end of this lesson, you're going to be able to identify parts of a circle, calculate circumference and area of a circle. Okay. And you got a nice pie chart meme there. Okay. So obviously we've seen circles in many places, right? You've got Ferris wheels, right? So we talked about the triangle with the Ferris wheel, the triangles, right, with the Ferris wheels. Here's another one, right? You've got the triangular supports there and the circular ride there. That's out in California. And pizza, circular in shape. Tires, money. So, I mean, you can think of anything, right? A circle is just another shape. And, you know, so we use these shapes. Have you seen during the year? We use different shapes and create different things. So, all right. Now, we want to look into what are the different parts of a circle and what is a circle? Like, how is it defined, right? So everything really in life, the place that you start is what is the essence of this thing, right? That's a great place to start in anything that you're doing. You know, what is English class? What is school? You know, what you're doing and what's the purpose of it, okay? So what is a circle? So a circle is basically... it's every point that's the same distance away from another point. Or put another way, it's all the points that are the same distance away from the center. Okay. So as you notice in that picture right there, you know, assuming that all those points are equal distance away from the center, if we were to fill in the circle, right, with even more points that were equally distant from the center, that would make a circle. Okay, so that's all it is, right? In the center of the circle is the point that is the same distance away from all the other points on the circle, okay? So, now there's three main line segments that we want to talk about: diameter, radius, and a chord. So the first one is a chord. So a chord is just a line segment that starts on one end of the circle and goes to another end of the circle, okay? That's it. The radius starts at the center point of a circle and it goes to the edge of the circle. Okay, so that's a radius. And then the diameter is basically two radiuses, we would say radii, two radii in a straight line. So it's basically two radii put together. Okay, a diameter always has to pass through the center of a circle also. So a diameter is a special type of chord, okay? Because a diameter starts and ends at the edge of a circle, and every chord starts at one end of the circle and goes to the other end. Okay, so again, here are some pictures for you. Excuse me, just so you can get the idea. So there's a couple ways to name a circle. We either say the word circle and the center point, or there's a little symbol that looks like a circle, and then you just name the center point, okay? So this circle is circle C, or the symbol right there and the letter C. Okay, so first thing we want to do, name three radii of the circle. So first thing we want to learn is how to identify different parts of a circle. So there's going to be three radii here. So remember, a radius has to start at the center and has to go to the edge. So CD would be one. CE would be another one, and CF would be the last one. Remember, they're line segments, so they need to have that line segment symbol on top, okay? All right, so those are the three radii right there. Now, you might say, could I call it DC, EC, and FC? Sure, you could do that. All right, next question, name two chords of the circle. So a chord, remember, goes from one edge of the circle to another. So AB is one chord and DE is the other chord. Okay, DE is also a diameter. Okay. Okay, so AB and DE. Next one, name the diameter of the circle. All right, so we just said that, that's DE. So diameter, it has to go through the center. Notice AB is not a chord because it doesn't go through the center, or AB is not a diameter, it is a chord. It's not a diameter because it does not go through the center of the circle. All right, so that's DE. All right, so let's look at this. Name the circle two ways. I just gave you the answer there. But yes, again, you would use circle X, or use that little symbol X. So it kind of looks like an eyeball or a target. So that would be the number 1, number 2. So those are the 2 ways to name a circle. Okay, next question. Name all radii, diameter, and chords. So radii, again, this is just a different picture, but it's the same thing. So I would just try and start at the center and find all the line segments that go out to the edge of the circle. So XV, that would be 1. XT, that would be another one. XZ, that would be another one. And, whoops, that's not what I want. XU would be the last one. Next one, diameter. There's only one, ZT. Okay. Chords. Well, with ZT, every diameter is a chord, so ZT, and then RS. Right, that would be the other chord in the picture. Okay. All right. So there you go. There are your answers. So again, the big things today: radius, diameter, chords. Okay. All right, let's keep it moving. All right, so radius and diameter are related. So remember, we said that 2 radii make up a diameter. So all you have to do is multiply the radius by 2, and you'll get the diameter. Or if you divide the diameter by 2, you would get the radius. So those are important relationships you need to know, and we'll do some problems based on that, right? So for example, the radius of a circle is 10 inches. What's the diameter? Well, again, the diameter is 2 times the radius. So the diameter is 2 times 10, which is 20 inches. Okay. Perfect. All right, next one. Diameter of a circle is 15 centimeters. What is the radius of the circle? Well, again, you could use either formula, right? There was the D equals 2R, or the radius equals diameter divided by 2. So I'm trying to find the radius, so I'll use that formula. Radius equals diameter divided by 2. So the radius is 15 over 2, which is 7.5 centimeters. So you don't have to use a formula. I mean, I'm pretty sure you can either multiply by 2 or divide by 2. But as long as you remember that 2 radii are equal to 1 diameter, then you're good. Okay, there's the answer. Okay, so we could also extend this out to problems, right, where we have variables in them, right? So in this example, QT is 2x squared and UQ is 8. Find x. Well, QT and UQ are both radii, okay? So they're both radiuses if you don't like the other word, right? So every radius in a circle has the same distance from the center to the edge of the circle. So every radius has the same length, okay? So we could say that QT has to equal UQ, right? They have to be the same because they're both radiuses. So then we could say 2x squared equals 8. Divide by 2, we get x squared equals 4. Take the square root, and we get x equals plus or minus 2. Now, the reason that we can do this, we can use the negative answer here, because if we were to plug back in here, we would get 2 times 2 squared, which equals 2 times 4, which is 8. And if we plugged in a negative 2, notice by squaring the negative 2, we would still get positive 4, and we would get 8 for QT. So negative answers could be allowed. Usually when there's something squared, negative will work out. But remember, in right triangles, you can't have a, or any triangle, you can't have a length that's negative, okay? So plus or minus 2 is the answer there. So there you go. Okay, next one. If UQ is 3x squared and TU is 36, find x, okay? Now this one's a little bit different, right? So just think about what you have. UQ is a radius, and TU is the diameter. So that's going to mean that two radiuses, right? The diameter is 2 times the radius. So the diameter here is 36, that's TU. The radius is 3x squared. So 36 equals 6x squared. Divide by 6. 6 equals x squared. Take the square root, and we get plus or minus the square root of 6 is equal to x. And no, there's nothing we can do because 6 doesn't simplify. It doesn't have any factors which are perfect squares. Okay? So we're done. So again, a lot of these are just small relationships. You have to do a little bit of algebra. Okay? Nothing to be too crazy about there. Okay? And there's the answer for you. Okay. All right, so finally we'll just finish up with some supplementary vocabulary. Okay? So, two circles are congruent if and only if they have congruent radii. Well, you know, if one circle is has a radius of 5 centimeters and another circle has a radius of 5 centimeters, then yes, they're the exact same circle. Okay, you don't really need to know that. It's just kind of like bonus information. All circles are similar. Now that's interesting, right? Think about why that's the case. Okay. Okay, then next one, concentric circles. So are two circles that have the same center. So think of concentric. Con means with, right? In Spanish, you know that, or maybe you do. Latin, we would say the same thing, con or cum, with. So con with. Centric, center. So with the center. And in this case, with the same center. So two circles that have the same center are concentric. Okay? All right. So we're going to stop it there. We'll pick it up next time with circumference and area. Okay? And yeah, so that we'll call it a day there. And